Okay, so a question came up over email on problem 2.5.27, and it's basically this question right here. Let's see, I'm not sure if you can see that. It says determine visually whether the function is even, odd, or neither. And they give you this function right here. Okay, so I'm just going to draw a sketch of this. And it's doing something like this. Okay. And when we're talking about even and odd functions, there's actually a couple of ways to determine whether a function is even or odd or neither. And one of the ways is to actually look at the graph and do a visual inspection. The other way is to actually look at the algebraic equation and then analyze that. Okay, so if a function is odd, odd functions have symmetry with respect to the origin. So that's what it actually means to be odd. WRT here means with respect to the origin. Okay, so what that essentially means is, if I have some ordered pair XY on my graph, then the ordered pair negative X, negative Y would actually be on my graph as well. Okay, so for instance, if I looked at, let's just say that point right there, and that's some point xy. If I took that point and I took the opposite of the x and the opposite of the y, if I then went and actually that point was actually on the graph of my function, then that would be something that is odd because it would have symmetry with respect to the origin. So you can see here that this would correspond to a negative x, negative y down here. Now there's no coordinates here, so you might say, well, how do you know that? And essentially, when you have symmetry with respect to the origin, it means can I flip it, can I flip the function down or up, either way? If I flip it down and then flip it over, is it going to map onto what's over here? Okay, so for instance, if I were to just look at like this piece right here, if I flipped that down, this is going to get a little messy, but let me just show you. If I flip that down, it would be down here, wouldn't it? Just to dot it. Okay, so if I reflected it across the x-axis, it would be down here. And then if I flipped this over, over my y-axis, could you see that it would actually, and I'm not to scale here at all, but this piece would actually map onto that piece right there. Okay, and this point would come here, and then when I flip it over, that point would go there. All right, so when you're looking just at a graph to see if it's odd, or even, you really can just inspect it. And odd functions have symmetry with respect to the origin. So this particular function is definitely odd because I can flip it down, flip it over, and it's gonna map directly onto what's there. Okay. Even functions have symmetry with respect to the y-axis. To the y-axis. Okay, so that means like, something like parabola is a good example of something that is even. So you can see here if I've got some point xy, and then if I were to take this arm of the parabola and fold it over my y-axis here. So just kind of taking half of my paper and folding it over, that this half of the parabola would map onto this half of the parabola. And that's symmetry with respect to the y-axis. So that tells us, if we have that type of symmetry, that tells us we have an even function. In this situation, if I have the ordered pair xy, xy is going to map onto a negative x and then a positive y. Okay, so you can see if this is xy, if I go over, negative x would be over here, and positive y would put me up here, so that would, again, show me that I have symmetry. Okay, so when you're looking at something graphically, you can simply think about flipping the graph. With the origin, can you flip it down and flip it over and get back to where you are, map onto the graph? Or, with symmetry with respect to the y-axis, can you just flip it over and have this half map onto that half? Okay. When you're actually doing this even odd stuff algebraically, you need to actually follow these definitions. And essentially what you do is you're going to plug negative x in, and if you get out the opposite of your function, then you have something that is odd. And if you plug negative x in and you get your original function back, then you have something that is even. Okay, so I'm just going to take a very basic examples for this because they weren't the ones that you asked, but I just want to cover it. It's like, let's say I have f of x equals x squared, and I already showed you that that's just a parabola, and you know that's even, so it has symmetry with respect to the y-axis. If I want to do this algebraically and answer this question algebraically, I would actually just plug negative x in, so I would evaluate f of negative x. And when I plug f of negative x in, you're going to say this is negative x, and I'm going to do whatever's being done to x right here, so I'm going to square it. Okay. When you square negative x, the negative gets squared and it actually becomes positive. So when I plug in my negative x here, I end up getting back my original function. So that is this situation right here where I've plugged in a negative x and I'm getting out a positive y. I'm getting back my original function. Okay, so this is what would tell me algebraically that I have an even function. Okay. All right, and then just a very basic example of something that is odd. F of x equaling x cubed, if you think of the x cubed graph, it's a squiggle graph that looks something like this. If I take this graph, I flip it down, flip it over, then this will map onto that. So that makes this an odd function. And we can see that easily looking at the graph. But if I wanted to analyze that algebraically, then I would say, well, let me evaluate f of negative x. When I plug that in and I cube it, you know, when you take a negative and you cube it, you end up getting a negative. So this would end up being a negative x cubed. Okay, this is the opposite of our original function, right? So the opposite of our original function here, it's a negative y. And so this is the scenario that dictates to us and shows us that we have an actual odd function here. Okay, I mean, you can get more complicated functions here for even and odd, and you just do the same thing to analyze whether it's actually even or odd. A neither function, when it's neither even or odd, is going to end up being, you know, the situation where it either doesn't have symmetry to either the y-axis or the origin, or it's going to be when you plug in a negative x, you just come up with something that is neither the original function or it's also not just the exact opposite of the original function. Okay.